rest of the corridor is going to look like. All right, so enough of me yabbering. Let's get on to R8 and let's solve some inequalities. All right, so where do we begin? Well, let's begin at the beginning. It's what it's for. And we're going from equations to inequalities. Inequalities are, they'll have the linear inequalities, will have the same format as a linear equation. So if you remember, linear equations look like this: ax plus b is equal to 0, where a and b are, everybody remember this, elements of the set of real numbers, and a is not 0, right? So this is the definition of a linear equation. All right, equation because of the equals in it. Well, now guess what a linear inequality looks like? It looks exactly the same except different. It's going to be ax plus b greater than 0, greater than or equal to 0, less than 0, or less than or equal. Same caveats, a and b are real, and a is non-zero. All right, so that's the only difference. Notice that not equals is not included here, right? I have greater than or equal to, less than or equal to. We don't include not equal to because it has some funky math that comes along with it. If you tell me two things are not equal and you add something to both sides, I don't learn or gain anything from it, so I don't get to carry over any rules. So notice that the not equal to is not one of the four. We've just got greater than or equal to, less than or equal to. All right, so let's knock these out. How am I going to solve these? How am I going to work these? They're going to work exactly the same way as a linear equation, except for one teeny tiny detail that everyone remembers from taking math in the past. All right, so I'm going to go ahead and just jump right into compound rather than taking the time to kind of double up on you. I'm just going to move it at once. Compound inequalities are inequalities that have at least two pieces. They're separated by or and. Okay, and each case is different. If it's an or, it means as long as x satisfies one of the two inequalities, my compound inequality is met, or it is true. When I have an and situation, I'll need to come up with values of x that make both inequalities true. So let's tackle these one at a time. If you're dealing with compound inequalities, you're going to deal with one and then the other, at least for this page. So the first one we run into is negative 3x minus 1, less than negative 4. These are all linear equations, so forget quadratics for a second. If it's linear equations, everything with an x to one side, everything without to the other. So I'm going to add 1 to both sides, getting me to negative 3x less than negative 4. Plus 1 is negative 3. And then immediately we trip right over the one piece that's different. I need x by itself. It's currently multiplied by negative 3. So I'm going to divide the left by negative 3. If I divide the left by negative 3, I have to do the same thing to the right. And what happens with an inequality? Negative 3 divided by negative 3 is positive 1. When I multiply or divide both sides by a negative number, whatever inequality I have flips direction. Okay. Why does that happen? Okay. It happens, and understanding this any deeper than what I'm going to show you is unnecessary. If 2 is less than 5, that's true, right? If I flip the sign on both sides, does this hold true? If 2 is less than 5, then -2 is less than -5. That's not true, is it? That's false. No, no. What happens? If I change the signs on both of them, what has occurred? Well, 5 is larger than 2, right? When I make them both negative, or when I change the sign of both numbers, -5 is smaller than -2. And it's a poor use of the word smaller on my part there, but think in terms of the number line. 5 is greater than 2 means 5 is farther to the right on the number line than the 2. How about the -5? The -5 is farther to the left than the -2 is. So whenever we have this occurrence, if you want to flip the signs, you have to flip the inequality. That is true. All right. Don't worry about the comprehension there any deeper than that. Just realize that if I know, if I'm given something and I know it to be true, 2 is less than 5, if I change the sign on both sides, in order to retain, in order to be true, right, my inequality has to change directions. All right. So, all right. Everybody cool with that piece? Thumbs up, hands up. Yeah, good, 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 good. All right, so let's find the cursor. There it is. And come back over here. So I had a compound inequality that's separated with an or. So I dealt with the left-hand side. I've got that. X is greater than 1. So this was the aside. And then the other portion of my compound inequality is 4x plus 3 less than -6. Same game, right? It's linear. Everything with an x to one side, everything without to the other. Everything with an x is already on the left, which means I'm looking at -6 minus 3 more is -9. And I want x by itself. I'm going to divide both sides by 9/4. Now, I divided, but I divided by a positive number. If I divide by a positive number, nothing changes with the direction. The inequality stays in the same direction. All right. Even though the number on the right hand side was negative to start with, that doesn't mean it doesn't do anything. It's all about the sign of the number that's being multiplied or divided. Right. On the left part of the compound, I'm dealing with negative. I'm dividing both sides by -3. That's why the inequality flips. On the right side of the on the second inequality, I'm dividing by a positive. The inequality doesn't flip. Now, how am I write this? How do I write this answer? Okay, well, this is an or. All right, so I'm going to just take these lines that I drew, and let's get our minds, get our heads wrapped around what's going on here. I have x is greater than 1. So what does that look like on the number line? Let's just let this be the number line. Here's 1, and I'm x is greater than 1. So that means everything to the right of it, right? That goes on, and it goes on forever. So you see how I'm highlighting that arrow? That's an indication that this continues on forever. When is x greater than 1? All the numbers greater than 1. That goes on forever and forever for us is to the right is positive infinity. How about the other? How about the other side of this? Well, x is less than negative 9/4. Okay, let's get negative 9/4 on the board. All right, and this is, so what have I found? I have found that this part of the compound inequality is true when x is less than negative 9/4. Negative 9/4 is negative 2 3/4, so everything less than that. So that means I'm going to the left, so shading in all of this, and that's going to continue forever. So when I go to the left forever, that's represented by negative infinity. Okay? Inequalities and equations are different with their solutions. Okay? Equations are typically going to have one solution, no solution, one solution. Sometimes they'll have infinite, but it's not as common. Inequalities, instead of you solving it and saying when x is this number, this thing is true, I'm actually going to get an entire set of numbers where it's true. That set is going to need to be represented in set notation. So how do I write it? Well, the first thing I want to point out is when x is greater than 1, does that include 1 or does that not include 1? X is greater than 1. Is 1 included in that? Yes or no? Is 1 greater than 1? It is not. Correct. So there's two ways to represent this on the line. One of them is an open circle. That's an old school way. The other one is a parenthesis. So if I'm writing this or drawing this out on my number line, you'll see me put a parenthesis right there at the 1. And then for the negative 9/4, same thing, right? This is strictly less than. The negative 9/4 is not included. So I'll get a parenthesis. Why do I bother with parentheses and or why do I do the parentheses and make all these notes? Because there's something called interval notation. And interval notation helps me write inequalities in a easy to understand way. So what I'm going to do is I'm going to say x is an element of, you're already comfortable with that notation. And then I'm going to write the set that contains it. Now, before this, the set had the curly braces, right, or the curly bracket. Doesn't have that now because the curly bracket is for when I can list all of the solutions. In this one, my solutions are all the numbers greater than 1. How do I represent that? Well, here's 1. I go off to positive infinity. The 1 is not included, so I indicate that to the reader by using a parenthesis. If it were included, I'd be using a bracket. And then infinity is a concept. It's not actually a number. So infinities always get a parenthesis. Okay. So let me try that one more time with confidence. Parenthesis. Parenthesis. There we go. All right, now for the other side of the compound, negative infinity to negative 9/4. When you're writing an interval notation, here's the nice part. If you have one of the arrows included, you have an infinity involved. And then if you have another number, the number is typically listed. So in my inequality here that I've drawn on the number line in green, I'm starting, I always read left to right here. So I'm starting out at negative infinity. And I go all the way up to negative 9/4. Okay, I do not include infinities ever. So that always gets a parenthesis, and then the negative 9/4 gets a parenthesis as well. Okay, so this is the interval notation solutions. Okay, now last step here is I have to appreciate, or I have to take into account that this is an OR. Right now I have two separate sets and I need to put them together. And I put them together using the union sign in set notation. I'm always going to start from left to right. So the smaller numbers are the ones in the green over here. So I'm starting negative infinity up to negative 9/4. That's one of the sets. The other set is the one in blue, 1 to positive infinity. And to put these together, I use a U. This is called a union, and it is synonymous with an OR. All right, so this is what my solution set looks like in interval notation. Interval notation is the tougher of the two. The other one is called set builder, and I'm not worried about set builder because it's really self-explanatory. So we have put together our solution. We've got our compound inequality. We have an OR. So all x has to do is meet one of the two requirements, and the two requirements for this compound inequality are negative 3x minus 1 is less than negative 4, or 4x plus 3 is less than negative 6. All right, so that is an OR. Now, of course, on the other side we have an AND. So let's tackle that one. The process is going to work the same way. The thing that changes is when I get to the end. So I have two parts. Left-hand side, or my left equation says x minus 5 greater than or equal to negative 2. Solve that for x. I want x by itself. To get x by itself, I'm going to add 5 to both sides, which means x is greater than or equal to negative 2 plus 5 is 3. That's done. Okay, and then the other part of my inequality is 7 minus 2x less than 3. I'm going to get x by itself, so everything with an x to one side, everything without to the other. I'm okay. 7 minus 7 is 0, but pay attention here. Negative 2x plus 0 is still negative 2x. Less than 3 plus negative 7 is negative 4. Notice the inequality did not change the directions because what did I do to both sides? I subtracted. I did not divide. Okay, but on this next step, I'm going to. This next step, x needs to be by itself. So I'm going to divide both sides by negative 2. And in doing so, I have changed the relationship, right? Negative 2 divided by negative 2 is 1, less than becomes greater than, negative 4 divided by negative 2 is positive 2. All right. So what have I got? Well, I have two inequalities. These are my solutions. So let's take a look at x is greater than or equal to 3. Okay, so here's 3. I'm greater than or equal to that. So greater than means go to the right forever. Equal to means 3 is allowed. So on there, I actually use a bracket instead of a parenthesis. So my interval notation for this portion is start at 3 and go to positive infinity. All right. And that's not, to be clear, that's not a parenthesis at the end. That's the arrow of the number line that's just highlighted. On the other portion, I have x is greater than 2. What's that look like? Here's 2. That goes on forever. Go on. I do not include the 2, so that gets a parenthesis. So that means this one looks like, start at 2, start just to the right of 2. Go to positive infinity, right? I have to write parenthesis 2 to indicate to the reader that 2 is not included, but everything greater than 2 is, okay? I can't put, most people see this and think, why don't you just put 3 instead of 2? Well, the reason is there are numbers between 2 and 3 that are answers, right? 2.1 is an answer because 2.1 is greater than 2. Anything 2 point anything is a solution. All right? So that's why parentheses have to be used for when we do not include the endpoints. Brackets are when we use it. Now, I'm bearing the lead here. This is an and. So instead of having two sets and I have to put them together, what I've actually got are two sets, and I want the numbers that make both of these true. So I'm going to plot this on one number line. Here's the 3, and I'm going to the right. That goes on forever. The 3 is included, so it gets a bracket. And then the 2 to infinity, here's the 2. 2 is not included, so that's a parenthesis, and that goes on forever. And I go to infinity. Okay? Because this is an and, the solution set contains all the overlapping values. So in terms of my drawing up there on the number line, it's everywhere that I have red and blue. Okay, so what are the values that have red and blue? Well, there's nothing to the left of 2 that's in either, so I don't have to worry about any of those numbers. 2 is not included in the red, so that doesn't have to worry about it. Between 2 and up to 3 is just blue, so that's not part of my solution set because this is an and. Okay, but once I reach 3, 3 is included in the 2 or greater than 2. 3 is included in the 3 or greater. And then everything to the right of 3 is included. So that means my solution set turns out to be everything 3 or greater. Whoa. 3 grew an extra hump there. 3 or greater. The 3 is included. The infinity is not. Yes, exactly right. Yep. Bracket because the 3 is in there. The 3 is contained in both portions of the compound inequality. Okay. Now there is a notation for this, just like we have the union on the left for the or. We do have what's called an intersection, and it's just an upside down U. But writing it doesn't make a lot of sense because when you write two sets that intersect, the answer to that is to simplify it down to just the numbers where they intersect. So there is a symbol for and, it is the intersection symbol, but we don't typically write it because it can look like the final answer if we're not careful. So we avoid that. All right. So these are going to come with practice, and practice is what's going to be required for this section. All right. So the next one I have, this is a compound inequality, and this one is another and situation. Okay. Because what's going on here? -3 is less than x plus 5 over 2, which is less than -1. X is trapped between two numbers. So I told you that my and up here on the top right, I've got it busted up into 2 pieces. Turns out when I have an and, it can be written like this. It can be written as one inequality with 3 sides. Let me That a bit larger. Hopefully that will help. All right. So when I have this, I treat it exactly the same. That I'm going to solve this for x. Okay. X is currently in the middle. I'm going to leave it there, but I do want to get it by itself. All right. Well, x plus 5 is currently divided by 2. So I'd like to get rid of that multiplication of that division by 2 by multiplying this by 2. If I do something to one part, one of the 3 parts here, I have to do it to all of them. So negative 3 times 2 is negative 6. I did not multiply by a negative, so my inequality doesn't change directions. X plus 5 divided by 2 times 2 leaves me just x plus 5. And then negative 1 times 2, negative 2. All right, x is almost by itself. Now I just need to get rid of that plus 5. I do that by subtracting 5. If I do it to one side, I have to do it to all. And I do my math here. Negative 6 minus 5 more is negative 11, less than x, less than negative 2 minus 5 more is negative 7. That is such an easier way. Now that I've got to the end, this is so much nicer when it comes to writing my solution in interval notation, because x is trapped between negative 11 and negative 7. So it's all these numbers. Are they included? Endpoints are not included because this is strictly less than, strictly greater than. So those are parentheses. So what's my interval notation look like? I start at negative 11, go up to negative 7, and I do not include either endpoint. All right. Examples moving in the right direction. Everybody cool? Okay. Like I said, the homework's there. There's plenty, and then there's plenty of opportunity for practice. Interval notation, just kind of learning that process, learning how it's written. It takes time and it takes practice. All right. So let's go on to page 2. And you've already thought about this, or have already brought this concept up. I want you to think about greater than inequalities with absolute values. All right. So this first question says, where are all the numbers with an absolute value greater than 2? All right. So write that as a inequality. What am I doing? I'm doing inequalities, but now I'm bringing absolute value in. All the numbers with an absolute value greater than 2. Absolute value is distance, right? Because the absolute value of 3 is 3. The absolute value of negative 3 is 3. Because both of these are 3 units from 0, right? Everybody remember that stuff? Right? Absolute values are just described as distances, right? How many units from 0 are you? 3 is 3 units from 0. Negative 3 is 3 units from 0. So where are all the numbers with an absolute value greater than 2? Somebody give me an example. Just tell me a number that would make this true. Some value of x that makes this a true inequality. Seven. Great. 7 is right here. 7 is more than 2 units from 0. 7 is part of the solution set of this absolute value inequality. What else? Give me some other numbers. 3. Great. Yep, 3's in there. Is everything between 3 and 7 in there too? Yep. Ah, very good. Yes. All those are in there. -10, right? Because when I plug -10 in for x, I get the absolute value of -10, which is 10, and 10 is greater than 2. So this inequality really reads as all values, or all, let me be very specific there, all numbers 2 to infinity, -2 to -infinity. There you go. All numbers more than 2 units from 0, which is super easy to see on this side, on the right-hand side, right? 5 is greater than 2, 10 is greater than 2. All of these are included, okay? But the trick is I have an absolute value, and Tiffany's already hit it. She pointed out -10 worked. Well, -5 is more than 2 units from 0. So it's in there. Everything just to the left of -2 goes on forever in that direction. So what have I got here? I have parentheses around the 2 and the -2 because this is strictly greater than, right? So where are all my answers? Well, all the answers from whenever I have an absolute value is greater, okay? I'm either I'm either exactly what I said, right? Would everybody agree that this side is x is greater than 2? Just this part of the number line that's highlighted, that's x is greater than 2. What's the other side as an inequality without the absolute value? Well, this is all the values of x that are less than -2. Okay? Let's rinse and repeat with 6 and 9. Absolute value of x greater than 6. You can already see where this is going. I'm to the right of 6, and I'm to the left of -6, because these are all the numbers that are more than 6 units from 0. This is the absolute. This is x is greater than 6. This is x is less than -6. What's going to happen when I do greater than 9? Same stuff, right? Now I'm at 9. Everything greater than 9 is in there. Everything less than -9 is in there. So this side is x is greater than 9, and this side is x is less than -9. Okay. So this is the idea. This is the concept that we're after. Okay. What do these look like graphically? Whenever you've got absolute value, and I have x in there right now, but it could be anything with x. It can have multiple terms. It can have it can have as much as it wants to inside. If x is inside there, if I have some algebraic expression with x inside that absolute value, my solutions are always going to look like this. I'm going to have either the inequality reads exactly like it is by dropping the absolute value sign, and I just have x is greater than 9, or I drop the absolute value bars, I flip the direction of the inequality, and I flip the sign. Right? Notice I either have x is greater than 2 or x is less than -2. I flip the direction and I flip the number. X is absolute value of x is greater than 6. X is greater than 6, or x is less than -6. absolute value of x is greater than 9, x is greater than 9, or x is less than -9. All right, so there's the generalization here at the bottom, and I've written it out in mathy terms because you all are smart and mathy terms are fun. Let's go a little larger here. So this shows if x, and now notice something's changed here. Notice and this is just a good point. Notice in my problems above, I have a lowercase x. In the right up down there below, I have an uppercase x. Uppercase x usually denotes an algebraic expression, meaning it can have multiple terms, some of which have x in them. Okay, so this shows that if some absolute, so some algebraic expression x and k, a real number, and that little thing right there just means positive real number. And that's what that little plus does. Then the absolute value of x is greater than k implies either x is greater than k or x is less than or equal to -k. How in the world are you going to remember this? How am I going to know what to do? What in the world? You're throwing everything at me and I'm getting confused. This is what I want you to remember. If the absolute value of x, and this is, I'm doing a capital X here just to draw attention to it, some algebraic expression is greater than x. Okay? Great. And I want you to misspell this on purpose. Greater. All right? If I have the absolute value of some algebraic expression is greater than some positive number, then I have an or situation where my algebraic expression is greater than k, or my absolute value expression is less than -k. All right. Great, or I've got that. Okay. Now, let's see what happens when I change the direction. What about the absolute value? Where are the solutions, or where are the numbers that have the absolute value less than 2? Okay. Think about this one again. Absolute value is distance. So this should contain all real numbers that are less than 2 units from 0. Okay. The first temptation here is, oh, absolute value is less than 2, so that means go to 2 and go to the left, right? Not exactly. That's not everything, because this one has some restrictions. This contains all the numbers that are less than 2 units from 0. So we agree that 2 is not included, and anything greater than 2 is not included. But 1 is included, right? -1's included. Right. Where am I limit? Everything in here is included. Everything between those is included. Where do I draw a line here? Where do I have a problem? Well, I can't be more than 2, or I can't be 2 or greater. So I'm going to draw my little parenthesis here. And if I go to the left of -2, now I'm more than 2 units from 0. So I can't go to the left of -2. So I need a parenthesis there. And what's my solution set, or what's my set? It's all of those. Exactly. Everything from -2 to 2. All right. Interval notation here. negative 2 to 2, parentheses on both. How about less than 6? Same thing. Here's 6, here's negative 6. As long as I remain between those two numbers, I satisfy the absolute value, right? So this is everything from negative 6 to 6. And then lastly, we'll do it again for 9. That's value x less than 9. 9 to negative 9, or negative 9 to 9, and then everything in between. So what does that look like for us? It starts to the right of negative 9 and ends to the left of positive. Okay. How is this different? Right? Before, it was a split. Right? On the last page, these great or gave us sets, gave us two sets. And we put them together, right? We have this great or. This is a less than, right? So the rule says if some algebraic expression is less than some positive real number, again, here's that less than, again, I know I'm misspelling this. I want you focusing on that and. If I have an algebraic expression that is less than some real number k, then that algebraic expression is true. Take a look at the absolute value up here. This absolute value of x is less than 9. I'm definitely trapped by 9, right? 9, I can't go any higher than 9. I can't get 9 or higher. So if I am less than k, my absolute value of x is less than k, I can't be any higher than k. But where does my other limit kick in? It goes all the way down to negative, whatever that k is. I'm trapped. Yes. All right. So these are the two situations you're going to encounter. Okay. You'll have a less than, and when it's an and, you'll take, just in your mind, come back, take a look at those. Remember, when it's an and, I'm trapped between two numbers. When it's an or, I'm typically either greater than some number or less than some other number. Okay. All right. And let me be super clear here. This is just as an example. I've got absolute value, let's do is greater than 3. And I'm going to let x be some algebraic expression. So what do I mean by algebraic expression? Something like that. Okay. Actually, I'm sorry, this page is less than, so let's do those. Less than and less than. So algebraic expression just means I've got terms where there's an x in there. Could it just be x by itself? Absolutely. Okay, but algebraic expression just means it could be anything, and it's just got x's in there. And what do I have? I have the absolute value of some algebraic expression. It's not an equation because I don't have an equals. Good. Good. All right, so I've got some algebraic expression is less than some number 3, and my rule says what? What's inside the absolute value is either less than 3 or greater than negative 3. Okay. Now, why are these useful pieces of information for me? Because whenever I'm dealing with problems like this, I'm always trying to solve for x. Okay. So x is 2x plus 1. I need to subtract 1. It's 3, -3 minus 1 is -4. And then x by itself, I'm going to divide everything by 2. Did not divide by a negative, so all my inequalities stay the same direction. X less than 2 divided by 2 is 1. -4 divided by 2 is -2. There's my inequality. And if I want to write that in interval notation, I start at -2, I go to 1, and then I do not include either. Okay. Now, why are these useful? Why are these properties useful? The properties are useful because if you have absolute values in an equation, you cannot do anything to the values inside the absolute values. Okay? You have to apply one of these two rules so that the absolute value can go away. This is the only way to get rid of them. Okay? Whenever you're dealing with absolute values, if x is inside the absolute value, you've got to get rid of the absolute values so that you can get in there and get to that x. All right. All right. So I want you to take 1 minute. I'm going to pause my screen and everything. Take 1 minute, and I want you to see what you would do with these two problems. You do have to switch when you do that if you have to divide by a negative, which you do have to, yep. All right, so what do I have here? I want to solve, I'm told to solve, which means I need to get x by itself. Yeah. Okay, I want to get x by itself. X is currently inside of an absolute value. Okay, well, can't do anything with x inside that absolute value. I need to get it to go away. All right, if I want the absolute value to go away, it's going to be, the only way to do it is one of these two rules. I either can get the absolute value of some, for what we were doing before, this little lowercase u here is the uppercase x that I was using. Okay, for some absolute value of u less than k is equivalent to, see what happens, once I can get it into this form, I can write it without the absolute value, which means I can start doing math with it. I can write it like this, I can write it like these, and then start doing math with it. So that means I need to get this by itself. So whenever I'm trying to solve absolute value equations or inequalities, my first step is to isolate the absolute value. So the absolute value is multiplied by 3, and then 2 is added to it. I've got to subtract that 2 from both sides. Okay? I know there's a great temptation to distribute that 3, but you're just not allowed to do that. If you do that, it will guarantee you get the wrong answer. All right, so subtract 2 from both sides. Absolute value is not by itself yet, right? It still has a 3 out in front, which means it's multiplied by 3. So I need to divide both sides by 3. Did that, and now what do I have? I have the absolute value of 5 minus x is less than or equal to 4. All right, now this is a less than, again, we're mispronouncing on purpose here. This is a less than, this is an and situation, right? My absolute value, the absolute of something is less than or equal to some real number 4. All right, some positive real number 4. So that means, what do I have? It's an and. So either what's inside the absolute value is less than or equal to 4. It's less than or equal to 4, and it's greater than or equal to -4. And then we're just going to solve that. I'm going to move this down. All right. X is not by itself, it's in the middle, but it's not by itself. It's 5 minus x. This is a positive 5. I want it to go away, so I need to subtract 5 from all sides. -4 minus 5 more is -9. 5 minus 5 minus x still leaves a -x. And then 4 minus 5 is -1. The x is not by itself, it's negative. So I need to divide that by -1. When I divide it by -1, I have to divide everything by -1. And when I divide all my sides by -1, that inequality changes direction. So instead of a less than, this is now a greater than or equal to, and then this is a greater than or equal to 1. Okay, so what does my solution set look like? X such that it is both less than 9 and greater than 1. What does that look like? From 1 to 9, I include both endpoints because the inequality told me to. Okay? If you're looking for the shortcut, it's all about that. If the equal to is there, it gets a bracket. If the equal to is not there, it gets a parenthesis. Now, I know the 1 and the 9 have switched places. That's just a result of dividing by the -1, which caused everything to change direction, so it feels backwards. But it is, if x is greater than 1 and less than 9, we start at 1 and we go up to 9. We don't start at 9 and go down to 1. All right, now let's tackle the next one. -18 is less than -3 times the absolute value of 2y minus 4. Isolate is the first step. And then let me tell you the other two while I was thinking about it. It's isolate, separate, and then liberate. All right, so isolate, get the absolute value by itself. Okay, -18 divided by -3 is +6. Inequality changes directions because I divided by negative. -3 divided by -3 is 1. Absolute value, 2y minus 4. Now, take a look at the rules that we have. The rules we have the absolute value on the left and the positive number on the right. This one's backwards, so it could be really easy for us to make just make a little mistake here. So I'm just going to swap the order. It's not going to change. I'm not doing any math. What I'm going to do is put the absolute value on the left, put the number on the right, and then just make sure that my inequality continues pointing in the same direction. So the big side is pointing toward the 6, the pointy side is pointing toward the absolute value. So that means it needs to go like this, right? I swapped the 6 and the absolute values, so that swapped the direction of the inequality. I didn't change anything, I didn't do anything, there's no multiplication or anything. I'm just changing the order. Why? Because my rules, the way that we've learned them is this is another less than. This is an and, right? So that means what's inside the absolute value is less than 6, greater than -6. All right, so do math, do math, do math, add 4 to all sides. And I'm looking at -2, less than 2y, less than 10. Divide by 2, divide by 2, divide by 2. And we find -1 less than y less than 5. Okay, and then we'll just get this last one in and then we'll call it, because I know, or we can finish that. We're stuck between, so my solution set looks like what? Y is contained, smallest number, largest number, and then are they included? No, -1's not included, the 5's not included. So this is my solution set. All right. Now, last one on this page. Absolute value of 2x minus 8 is greater than -14. So what do I have here? This is a great or, right? We love a greater, because what does it mean? Absolute value has already been isolated. It is by itself. So that means absolute value of some algebraic expression greater than some positive number. Ooh, wait a second. Something odd's going on here. What's off about this? Here's the problem. This is negative. Okay. So this question is asking, when will the absolute value return numbers, greater, I misspelled greater by accident there, greater than -14. Okay. Well, what's the rule? The rule for us is that for a real number k greater than 0, these are the cases. This is k is greater than -14. Can the absolute value return negative numbers? Is that possible? Is there any number that if I take the absolute value of it, I get out some negative number? Is that possible? No? All right. This will never return a negative number. What does that mean for us? That means that no matter what you plug in for x, when you take the absolute value of whatever you plug in for x, multiply by 2 and subtract 8, it's always going to kick something back greater than -14, because it's always going to be 0 or positive. So the answer here is all real numbers. I don't even have to do any math. How do I write all real numbers? Start at -infinity, I go to positive infinity, or I do that double barred or. Okay. The reason this is the answer is because they ask us what are the x values such that this is true. And what they want to know is true is when is the absolute value going to return something greater than -14? What if I change the problem to say, when is 2x minus 8 going to return something less than -3? Okay, when is the absolute value going to return something less than -3? Never, exactly. This will never happen. So the solution set here is called the null set. It looks like that. All right. So we'll stop there. I'll do the video. I like this, doing the video on the rest of the notes, and then you can bring questions with them next time. So any questions out? Anybody got anything outlying? Anybody got some trouble or problems? All right. If there's nothing else, we'll call it a week here. I'll work on the videos tomorrow, have everything up for you, and we'll talk about the end of R8, and we'll review for the test on Tuesday. All right, y'all have a good day. What we're going to do with the next file type. All right, so we've gotten through the first 4 pages. We have 3 left. So I know Tinny, you said you had a question. If you don't mind, let me finish and make sure we don't answer your question in the rest of the lecture. And then when I get done, then we'll just do questions from R8, questions from the test review, any of the things you want to. All right. All right, so back in, we are diving right back into solving absolute value inequalities. There are the 3 steps. Okay, the cardinal rules of absolute value. Number 1, isolate the absolute value. 2, separate the absolute value. It's either going to be a greater, which is an or. So that means you're either going to have what's in the absolute value is exactly what it says, or it's the opposite direction for the inequality and the sign of the other side goes negative. If you, then the other case is you have the absolute value is less than. That's the and situation where what's inside the absolute value is either it has to be both less than exactly what's in the absolute value and greater than the opposite. Okay, so let's tackle these and see what we come up with. So I'm solving for 5 times absolute value of 2c plus 7 plus 1 greater than or equal to 11. And then since we're at the beginning of class and we're getting our minds warmed up here, let's just remember exactly what's going on. I'm asked to solve this inequality. It's an inequality because there's not an equal sign in there, there's a greater than or equal to. So I'm asked to solve, which means I need to get c by itself. C is currently inside an absolute value. The only way to get c out of the absolute value is to isolate the absolute value, because that's the only way I'm allowed to take the bars off. Right? I can't multiply or divide by both sides. I can't do anything to what's inside those bars until I have just the absolute value is some inequality to some other side, something on the other side. So in this case, I'll end up with the absolute value is greater than or equal to some number. So I need the absolute value by itself. It's currently being multiplied by 5 and then having 1 added to it. So I'm going to get rid of the 1 first. And the reason is if I tried to divide by 5 first, I would have to divide this 1 by 5, which means I would have the absolute value 2c plus 7 plus 1/5, and then subtract the 1/5. We don't like fractions, or students don't typically like fractions. So that's why we get rid of the 1 first, right? Everything with the absolute value on one side, everything without on the other. 11 minus 1 is 10. And then I told you you can't do anything, you can't do any math of what's inside the absolute value, but you can divide something on the outside. The 5s divide away, leaving 1s, and then the 10 and the 5 reduce to 2. So I've got the absolute value of 2c plus 7 is greater than or equal to -2. That is a greater, right? And when I have a greater, it means I got two things going on. Either the absolute value is exactly what it says. You just rewrite what's inside the absolute value. You leave the inequality alone. You leave the right-hand side alone. Or it's the exact opposite, which is what's inside the absolute value stays exactly the same. The inequality changes directions, and the sign of the other side changes directions. Solve both of these individually. -7 means, I'm looking at it, 2c is greater than or equal to -5. And then get c by itself, divide by 2, divide by 2. C is greater than or equal to -5/2. Or, okay, the two steps to get c by itself are exactly the same. Notice that it subtracts 7 on both sides. And then my answer is different on the right because I started out with a -2. And then I'm dividing by 2. Does everybody understand what I mean there? I said the steps are the same. In both sides, I subtract 7 from both sides. I divide by 2. The process of getting there is the same. All right, so here I am. C is greater than or equal to -5/2, or C is less than or equal to -9/2. Let's take a look at this on the number line. In order to do it, we're going to have to think about fractional negative numbers, which can be very difficult. All right, so just not for notation's sake, but just as a little aside, -5/2 is -2.5, right? That's 2 goes into 5 twice with a 1 left over, so that's 2.5, which is 2.5. -9/2 is what? 2 goes into 9 4 times with the 1 left over. So yeah, -4.5. Let me do that to the other side too to clear, just in case. There's nothing worse than trying to look at these notes after class and you can't figure out what in the world I meant. Okay. Why did I bother to do that? Because it's a whole lot easier to put -2.5 and -4.5 on the number line than it is to put -5/2 and -9/2. So they are where? -4/5. If I'm starting on the left and I'm working my way to the right, the first number I'm going to hit is the -4.5. And then the other one is -2.5. Now the question is where do these go? Which direction are we going in? C is greater than or equal to -5/2. That's the -2.5. That's going to correspond to everything to the right of -2.5. And does it include the -2.5 or does it not include it? Yes or no? Yes. Yes, it does. All right, so it is included, which means this gets a bracket. And then to go on to the other side, C is less than or equal to -9/2. -9/2 is the -4.5. So I'm looking at all the things less than that. So that goes all the way to forever. And just like the other, this is included. They're always going to be the same unless you get a problem set up where it's an and and they've told you the sign, one's greater than or equal to, one's strictly less than, or one's strictly greater than, one's greater than or equal to. When you're solving these absolute values, it's always going to be, if one side has the endpoint included, the other side is going to as well. Okay. So I've got what? Well, I have all the numbers less than negative 4.5. Well, that's negative infinity to negative 4.5. And then I have the negative 2.5 off to positive infinity. So that means my answer is what? Well, negative infinity. Infinities always get a parenthesis because you can never capture infinity, right? Up to negative 4.5, it's included, which is why the bracket pops in. And we have the negative 2.5 off to positive infinity. Infinities are never included. Negative 2.5 is included, so it gets a bracket. And then to join two things in that notation, I need that union symbol. So that's where the U comes from. And there's our answer. All right. What does this mean? This means that all of the numbers less than or equal to negative 4.5 or greater than or equal to negative 2.5 all satisfy the equation above and make it a true statement. All right. Okay. Not too terrible. I know it gets weird because now instead of just having one answer, now I've got an infinite set of answers, which means I have to write them as a set, and I can't just write x equals 4 and then do the brackets and then just list all the answers in it, right? Because I can't list all of these numbers. So remember, that's why we're using this interval notation. The book talks about set builder notation, and I'm just going to show you what that would look like. So it starts out with a bracket, and you get C. You get a big straight line. It looks like half of the absolute value. It's just a straight line, straight vertical line, and it reads as such that. And then what you do is you put in the inequalities that you found. C is greater than or equal to negative 5/2, or C is less than or equal to negative 9/2, and you close parenthesis, or excuse me, you close the curly brace, curly bracket. Okay, so this is called set builder notation. And then this is called interval notation. I think everyone would agree set builder notation looks easier because we don't have to convert over to interval notation. You're right, it probably is. Which one should you use? You should use the one that the book, that Alex is asking you to use to get the right answer. And typically when you bring in a computer to try to tell if the answers are right or wrong, the interval notation is typically the way it's going to go, because it's really easy for the computer to determine, did you write that correctly, versus, you could swap the order of the C's and you got an or in there to get that set builder notation in there. All right, so isolate, separate, I isolated, I separated, and then liberated by getting the C's out and now by themselves. So let's take a stab at this one. Okay, well now they've gone and done something else, right? Now they've added some rational expressions to this. Now I have the absolute value of 3w minus 2, all divided by 2, plus 6 is less than 8. Okay, again, you don't know how to do this problem yet, but you can make it look like a problem you know how to do very easily. Anytime we've got these fractions, and we have two sides, we have an equation or an inequality, the best thing to do is get rid of those fractions or clear them if you're allowed to. Are we allowed to? Yeah, I can multiply both sides by 2, right? The LCD of this whole inequality, all three terms here, is 2, because 2 is the only thing, is the only denominator we have. The 6 is over a 1 and the 8's over a 1. So if I multiply both sides by 2, what does that do for me? Well, it takes away the denominator from the absolute value term. And now 6 times 2 is 12. 8 times 2 is 16. And now this is a problem you can do. Right now, this is a problem that you absolutely know how to do. So let's subtract 12 from both sides. So you see how one technique from a while back and then one technique, one new technique come together to get you what you need. So what am I looking at? This is the less than, right? So if it's a less than, it means whatever's inside the absolute value is bounded or trapped between whatever it's less than and greater than the opposite sign of the right-hand side. So if your absolute value is less than, that means my numbers are trapped between 4 and -4, right? Because what is, you remember the idea of if the absolute value, some absolute value is less than 4, that means the answer is all the numbers that are less than 4 units away from 0, right? That's why it gets trapped on both sides. Absolute value is gone. It's been, the absolute value is gone, but W is not by itself. So again, we feel the need to get W by itself, or we have that need, and the process is the same as before, 3W minus 2. Everything with the W needs to be by itself. Everything without a W needs to go away. If I add 2 to the middle, I've got to add 2 to the left and the right. And then the last step, get W by itself. It's currently multiplied by 3, which means dividing by 3 will get rid of it. I divided, but I didn't divide by a negative. So my inequalities do not change directions. And here's what I end up with. Negative 2/3 is less than W, which is less than 2. All right. Want to write that in interval notation. I'm starting at 2/3. I'm going up to 2, and then I take my step back. Is negative 2/3 included? No, because this is a strictly this is a strictly greater than, or excuse me, less than. So since it's strictly less than, it's parentheses. Strictly less than on the right, parentheses. Don't worry if you're not sure which one's a less than, which one's a greater than, if you don't know how to read it. It just takes time and you still forget it sometimes. Yeah, just don't let that bother you. As long as you can get our answer, figure out our absolute value, get it to the less than situation or the greater situation. And then remember, the parentheses indicate the endpoints are not included in the solution set. So that means negative 2/3 is not allowed and 2 is not allowed, but everything between those two is allowed. Okay? Any questions? Okay. Y'all are like eerily quiet today. Okay. So if there are no questions, let's tackle this last question. And I do want you to just take a note. The number has changed in yours, in your problem, it says on the right-hand side, you have less than or equal to something. I can't read it anymore. Less than or equal to some number. I have swapped that number out for -20. I think it's -2, but I don't know. So on the right-hand side, instead of whatever you had, replace that with -20. Okay? And the reason for that is if you don't, the solution comes out and it just makes a big old mess. All right, so this is looks complicated, looks nasty because fractions have appeared. Now they're inside the absolute value and there's work to be done. Don't let hard work scare you. It is not that bad. I want to isolate the absolute value. So everything with an absolute value goes to one side, everything without goes to the other. That means that -14 needs to go away. And I get rid of that by adding it to both sides, which means I now have -2 times the absolute value of 3/2 x plus 6 is less than or equal to -20 plus 14 is -6. And now I have to do I deal with the devil here, divide both sides by a negative. And it's fine for you to do that, but remember it's going to impact your absolute value, right? So that means, or excuse me, not an absolute value, it's going to impact my inequality. My sides are still, on the left-hand side, the absolute value is now by itself. On the right-hand side, -6 divided by -2 leaves me a +3, but my inequality was less than or equal to, and now it's greater than or equal to. All right, and we wouldn't typically write that plus. Okay, so questions. Everybody good with that? So we made our little, there's our hiccup for these. And what have I got? I have a great TOR situation, which means this splits into 2. Either 3/2 x plus 6 is greater than or equal to 3, or 3/2 x plus 6 is less than or equal to -3. If two numbers are left, the absolute value bracket. Oh, so that negative, when that -2 is over there, that means that 2 is multiplied. So that is that 2 is multiplied by, it multiplies everything inside the absolute value. Trouble is I can't distribute it because I'm not allowed to do math inside the absolute value. So that's why I have to get rid of it with the division. The -14, so that's -14 minus the term with the absolute value in it. So that -14 over there, it could, you could rewrite the problem or write the problem as 3 x plus 6, and see this is minus 14, or plus -14. It's just there's a -14 on that side. Okay. And to get our answer, what we need to do is take -14 and then subtract 2 times the absolute value. So it's just sitting over there. It's sitting over there in the same way that if I wrote -14 minus 2x is less than or equal to -20, solve for x, it's the same idea. That 14's over here. Everything with the absolute value stays. Everything else goes. That's why I add 14 to both sides. Right? If it helps algebraically, you can always, let's see, problem with something like this. Should I assume that add or subtract? Yes, absolutely. Yes, you should assume that. And the reason I know so you can't read the notes. Like I can't see a problem with something like that. Should I assume something in that place is added or subtracted instead of multiplied? Yes, you should. And the reason is because this minus 3 halves x plus 6. So the terms are separated. So negative 14 is a term, and then the 2 times the absolute value is a term. Terms are separated by pluses and minuses. So yeah, if it's separated by a plus or a minus, it is added or subtracted, which means adding or subtracting is the way to get rid of it. If there is no operator between them, such as the 2 and then the absolute value, if there's nothing between them, that implies multiplication, which means to get rid of that, I've got to do division. Okay, good questions. And the same thing if the negative 14, if it was minus 14 and it came after the absolute value, but it was still on the left-hand side of the inequality, same idea. It's subtract 14, or I need to get rid of that subtract 14, so I add 14 to both sides. Okay. So I've got my 2 inequalities, and I'm going to do the same thing as I did before, and I'm going to just do it to both of them. That fraction in there is going to cause problems if we don't do something about it, because multiplying or adding and subtracting fractions is where everybody's head just gets messed up. So 2 times 3 halves is 3x, plus 6 times 2 is 12, greater than or equal to 6. Everything with an x to one side, everything without to the other. And now I'm looking at 3x greater than or equal to 6 minus 12 is negative 6. And then divide both sides by 3. And x is greater than or equal to negative 2. That's one of them. Now we'll go the other direction. Same thing, I'm clearing the fractions. Distribute that 2, and I'm looking at 3x plus 6 is less than or equal to negative 6. No. I didn't distribute, did I? Distribute. 6 times 2 is 12, Larry. Some alarming news. 6 times 2 is 12. Everything with an x to one side, everything without to the other. 3x is less than or equal to negative 18. I want the x by itself. That means I got to divide both sides by negative 3 or by positive 3. Again, I divided, but I did not divide by a negative, so the inequality stays the same. Less than or equal to negative 6. The number line again is helpful. Notice there's not a fraction now, so I don't really have to rewrite these numbers to help. Here's negative 6, here's negative 2. I know my answer contains everything less than negative 6 up to and including negative 6, and everything greater than negative 2 starting at negative 2 and including it. That means my solution set looks like what? Start at negative infinity, go up to negative 6 and include it. Then skip over all the numbers between negative 6 and negative 2, pick up at negative 2 and go to positive infinity, put them together with that union. Now, the note at the top says example of interval testing. So what I want you to do, or what I want you to notice about this is we're saying not just that negative 6 works, everything less than negative 6 works. We're saying that if the number's between negative 6 and negative 2, it's not a solution. And if I have a number greater than negative 2, it is a solution. So we can do a check of our intervals to see if we're right. So this left-hand side, I'm going to pick a number in there, I'm going to pick negative 10. And based on our answer, negative 10 is in the solution set. So that means what? If I plug negative 10 in for x, 3/2 times negative 10 plus 6 less than or equal to negative 20. If I plug that in and then work the problem, when I get to the end, I should get something back that is true. Do I? Let's find out. Negative 14 minus 2, negative 3/2 times negative 10 is negative 15. Negative 15 plus 6 is negative 9. And now I can take the absolute value. All the math inside is done. So I can take the absolute value of negative 9. And that is what? 9. Two times 9 is 18. This is minus 2 times 9, which means it's minus 18. Negative 14 minus 18 more gives me negative 32, which is less than or equal to negative 20. That is true. So that means that interval checks. Everybody understand the idea here? If you plug in negative 1 million to this, it will come back true. Because not only is negative 6 of the solution set, everything smaller than negative 6 is in there. Same thing goes for the right-hand side. Everything greater than negative 2 is in there. So if you want to check that one, I would argue, whenever you get a chance, check 0. Because 0 usually makes the problem a whole lot easier, because it makes at least whatever, all the terms that have x in them go away. 3/2 times 0 plus 6 less than or equal to negative 20. I plugged in 0, so that means I'm looking at the absolute value of 6. Absolute value of 6 is 6. Careful not to do any math with the 6 until the absolute value has been removed. So it's negative 14. 2 times 6 is 12, so that's negative 14 minus 12 more. Negative 14 minus 12 is negative 26. Negative 26 is less than or equal to negative 20. That is true. All right. So both of those do work. Both of those check. That's exactly what we expect. Now let's find one that doesn't. So numbers between negative 6 and negative 2. I'm going to go with negative 4. And the reason I'm going to do negative 4 is take a look on the inside of the absolute value. See that 3/2 in there? That's going to then times x. If I put something that is a multiple of 2 in there for x, that fraction will go away. And if the fraction goes away, it just makes the whole problem a lot easier to work. So we're going to check negative 4, and then we'll take questions for the test. So check negative 4. If I did the math right, if my answer is correct, then this should return something false. All right. So negative 14 minus 2 times absolute value of 3/2 times negative 4 is 3 times negative 2, which is negative 6. Negative 6 plus 6 is 0. How far away is 0 from 0? It's 0 units. Notice that I took the absolute value of 0 and got 0, and then I do math with it. 2 minus 0 is 0. Negative 14 is less than or equal to negative 20. That is false. So that means exactly what we thought happened. Okay. The other time interval testing is useful is if you have a complicated problem, if you can figure out all the times where your inequality goes positive to negative, you can just test those intervals. But I'm not going to push that topic. I'm not going to push that way of doing it. I like the way we're doing it here, so I want you to stick with this. But this is the idea, and this is interval testing as well. Okay, it's useful for inequalities because I have entire sets of numbers. Interval testing is not useful for solving equations because equations usually have one or two, some finite number of solutions, 1 or 2 or 3 solutions. All right. Any questions? That's the end of R8. All right. If there aren't any, how about you tell me the questions? I know there were questions. I was told there were questions from Alex. Let's go in here. There's number 5 from R8. Perfect assignments. Here's R8. And I'm looking for number 5. And what I'm going to do is I'm going to paste the answer, paste the question over so everybody can see it. Solve the compound inequality. 3u plus 6 is less than 3, or 4u minus 5 is greater than negative 21. Write the solution. So we're going to tackle them both. This is an or, so I got to get after both of them here. 3u plus 6 less than 3. Everything with the u to one side, everything without to the other. That's 3u less than. 3 minus 6 is negative 3. I get u totally by itself, so I divide both sides by 3, and that means u is less than negative 1. My other side says 4u minus 5 is greater than negative 21. Everything with the u is already on the left, so everything without needs to go to the right. Add 5 to both sides, and I'm looking at 4u greater than negative 21 plus 5 is negative 16. I want u to be totally by itself. Divide both sides by 4, and I find that u is greater than negative 4. So, what do we have? I really like doing the number line when I get one of these because of the special case of what's happened in this problem. And because it just helps you with your ideas here. So I'm going to do the less than negative 1 in red and the greater than negative 4 in blue. Negative, these are the two numbers that I'm going to encounter. There's negative 4, there's negative 1. And for negative 1, I don't include negative 1, so that gets a parenthesis, but I do include everything to the left of it. All right? And then for the greater than negative 4, I don't include the negative 4, so that gets a parenthesis, but I do include everything to the right of it. All right? Now, here's something we haven't seen before. These intervals, this is an or, and the intervals overlap. Remember, the rule says when I have an or, it only has to satisfy one of the two. Typically overlaps are things we see with an and situation, but this one's an or. So anywhere on that number line that has the color red or the color blue or both is a solution. That's every single number up there, right? So since that's every number up there, that solution or the solution set is everything. And everything is start at negative infinity, go to positive infinity. Okay? The other funky one that you can get is a case where you have an and, but the two intervals don't overlap at all. When that happens, that is when this comes into play. That's the empty set. I mentioned it in passing, I think right there at the end of class last time. So you can, click that and put that in as your answer. And then let me show you, I don't know if they do, if the shorthand works. No, it doesn't. So now you have to click negative infinity, comma, infinity. Oh, don't put negative infinity twice because that's wrong. To infinity. Okay. And yet the notation, this one doesn't make you put the u as an element of, and because it just says give me the interval. All right. And you should take a look at if you take a look at this and you think, do I need to put u as an element of? There is no is an element of symbol. So that means I can't type it, which means it's not part of the answer. All right. What else? What other questions do we have? Any questions from the review? Question 5. Okay, question 8. All right, and we're looking at the review now. Let's take a look at question 8 in the same section. Question 8. Question 8 says, graph the solution on the number line. All right. I got a feeling this is more of a data entry problem than a mathematical one. So I have in there, this is one of those less than, right? So that means whatever's inside the absolute value is either less than 9, which is exactly what it says, but it also has to satisfy, I don't know why I put an equals there, it also has to satisfy the fact of being greater than negative 9. Okay, so I'm going to solve this for w, which means get w by itself. Negative 9 minus 12 more is negative 21. And then 9 minus 12 is negative 3. And now we make our deal with the negative gods. I can divide both sides by negative 3, but in the process, I have to flip my directions. So my less thans become greater thans, which means the problem looks weird, right? So let's read it. Let's see, what does this mean? This means W is less than 7 and greater than 1. Whenever the inequalities get flipped like this, it's always helpful to flip everything back in the way you're used to. So what we're used to seeing is when we have an and situation and we get the solution, it means that have a number less than or equal to the variable less than or equal to some number. So if I wanted to switch the directions without changing anything mathematically, I'm going to start at 1 and then W and then 7. And I'm just going to write the inequalities, but I'm going to match up everything. So if this is W is greater than 1, right? Well, W is greater than 1. That's W is greater than 1. It's also 1 is less than W. They're the same thing. Okay, and then 7 is greater than W. 7 is greater than W. All I did was make sure that my inequalities kept the relative side toward the same thing. In this greater than, the 7 is the symbol is open toward the 7 is closed toward the W. Open towards the 7, closed towards the W. In this one, the W, it's open towards the W, it's closed towards the 1. Open towards the W, closed towards the 1. So what's that going to look like on my graph? From 1 to 7 is covered, and instead of brackets and parentheses, they're going to use, when you're plotting this on a number line, they're probably going to use open and closed circles. So let's see if that's the case. And so, yeah, all right. So 1, oh, okay, so if I just click interval, it just does everything. Yes, I will. So what I need to do is pick my endpoints. So there's 1, there's 7, and then the interval means it's either select all the numbers less than 1, all the numbers between 1 and 7, and all the numbers greater than 7. So the only answer I said was the numbers between 1 and 7, not including 1 and 7. So you set your points or set your endpoints. If they're parentheses, open circle. If they're brackets, closed circle. And then highlight the intervals or intervals that are in the solution. All right. So there's